They were finding the bodies at dawn, floating belly up in the shallows of the Victoria River, Northern Territory, Australia.
No wounds. No bite marks.
No blood in the water. Just crocodiles, some of them nearly 2 meters long, dead, with their pale undersides turned to the sky like capsized boats. Rangers had worked this river for decades. In 20 years of patrols, a single dead crocodile was considered unusual enough to report. Now they were finding dozens, and none of them showed any sign of what killed them. The first assumption was disease. The second was water contamination, runoff from nearby cattle stations, maybe, or some chemical event upstream. Scientists flew in and took samples. The water was fine. They ran necropsies. The organs looked normal. No parasites, no tumors, no wounds that would explain an apex predator going from alive to floating in what appeared to be a matter of hours. Whatever was killing them was leaving no trace. And it was doing it to the one animal in northern Australia that nothing is supposed to kill. Before you can understand what took these crocodiles down, you need to understand what the freshwater crocodile actually is in the food web of northern Australia. Not the movie version. The real one. The saltwater crocodile, Crocodilus porosus, is the largest reptile on Earth. Adult males routinely reach 5 meters and weigh over 1,000 kilograms. They have been on this planet, essentially unchanged, for more than 200 million years. They survived the asteroid that killed the dinosaurs. They survived every ice age, every mass extinction, every geological upheaval the planet has thrown at life. They are, by any measure, one of the most successful predators in the history of animal life on this planet. Their cousin, the freshwater crocodile, Crocodilus johnstoni, occupies the rivers, gorges, and billabongs of northern Australia. Adults reach 2.5 meters. They have the fastest strike of any crocodilian species. And in their world, they sit at the top. Fish fear them. Birds avoid the banks near them. In the rivers of the Northern Territory, there are on average 5 crocodiles for every single kilometre of waterway. 100,000 of them in the Northern Territory alone. Nothing in that ecosystem predates an adult crocodile. Nothing has the tools. Nothing has the mass. Nothing would try. And yet the bodies kept appearing. Long before the scientific reports, locals had been telling the same story. Naturalists working remote river sections had been logging what they described as anomalous mortality events. Groups of crocodiles found dead in areas with previously stable populations. The bodies weren't always fresh. Sometimes already scavenged. But the pattern was consistent. Dead crocodiles, appearing in clusters, with no external cause of death visible to the eye. The record stretched back to at least 2005, mostly in the drier, more remote stretches of river in the semi-arid Northern Territory. And they all shared one detail no one had connected yet. The locations were specific. Upstream gorges. Sections of river that thinned dramatically in the dry season, leaving small, concentrated pools. Isolated water sources surrounded by dry rock and scrub. The dry season pools were the first real clue. Nobody had understood it yet. The second clue came from a necropsies. When researchers began cutting the dead animals open instead of just examining them externally, they found something inside. Something with no business being the last meal of a top predator. Inside the stomach of dead crocodile after dead crocodile, they found the remains of toads. This is where the story breaks from everything you expect. The animal they found inside those crocodiles is not a predator. It has no claws worth mentioning. Its teeth are vestigial. Its legs are stubby and its movement on land is closer to a waddle than a sprint. It weighs, on average, about 1.3 kilograms. A large one. The cane toad, Rhinella marina, was not supposed to be a threat to anything except beetles. That was the entire premise of its introduction. In June 1935, an Australian government entomologist named Reginald Montgomery travelled to Hawaii and collected a breeding sample of cane toads. He brought them back to an enclosure near Gordonvale in North Queensland. By August 1935, they had reproduced in captivity and 2,400 were released into the sugarcane fields. The plan was simple. The toads would eat the cane beetles, destroying the crops. Nobody had tested whether this was true. Nobody had studied what the toads might do to the surrounding environment if it wasn't. One prominent entomologist at the time, Walter Froggatt, raised the alarm publicly, writing that this great toad, immune from enemies, breeding all year round, might become as great a pest as the rabbit. The authorities dismissed him. The release went ahead. Froggatt was right. The cane toads did not control the beetles. The beetles lived high on the sugarcane stalks, and the toads were ground dwellers that couldn't reach them. The economic problem remained. The toads, meanwhile, found themselves in a subtropical environment with abundant food, warm temperatures, no natural predators, and nothing that had evolved to deal with them. They bred. They spread. They moved west and south. For 90 years they kept moving. Today, the estimated cane toad population in Australia is 200 million. They occupy 1.2 million square kilometres of the continent. 101 animals in 1935. 200 million today. A biological mistake that has been spreading and killing for 9 decades with no end in sight. And the freshwater crocodile of northern Australia had no idea what was coming. Here is what nobody understood about cane toads until native Australian predators started dying. The cane toad carries a weapon it doesn't choose to use. It doesn't hunt. It doesn't stalk. It doesn't attack. It simply exists. And everything that tries to eat it dies. Behind each of the toad's eyes sits a large gland called the parotoid gland. When a predator bites into a cane toad, those glands release bufotoxin, a milky white fluid containing compounds called bufadienolides. These compounds are cardiotoxic. They block the Na+K+ ATPase pumps in cardiac muscle, the mechanism that keeps the heart beating in rhythm. The result is arrhythmia, then seizures, then cardiac arrest. It doesn't take much. The lethal dose in most predators is measured in milligrams per kilogram of body weight. The toxin absorbs directly through the mucous membranes of the mouth, which means you don't even have to swallow the toad. You just have to bite it. For most Australian predators, the first encounter with a cane toad is the last one. Georgia Wardfear, a conservation scientist at Macquarie University in Sydney, has described what it looks like when a crocodile eats one. It's not pretty. They go into seizures. And death is fairly quick and probably very painful because it's essentially a massive cardiac arrest. A crocodile that has survived floods, droughts, territorial fights, and 200 million years of planetary upheaval is dead within minutes of biting something the size of a coffee mug. The researchers who first documented this at scale were Mike Letnick and colleagues from the University of New South Wales, publishing in the journal Biological Conservation in 2008. They surveyed freshwater crocodile populations in 4 sites along the Victoria River, 180 to 300 kilometres from the town of Katherine. They counted crocodiles before and after cane toad arrival. The results were not ambiguous. At the junction of the Victoria and Wickham rivers, crocodile population density crashed by 76.9% immediately after the toad invasion front moved through. Across all 4 sites, the average drop was 45%. Before the toads arrived, the researchers had not documented a single dead crocodile in the entire study area. After the toad invasion front passed, they found 34 corpses. Of the 71 dead crocodiles dissected across the broader study, 62% had cane toad remains in their stomachs. In the hotter, drier, more isolated gorges upstream, the places where the rivers thin to pools during the dry season, where crocodiles and toads are forced into the same small patches of water with nowhere else to go, the kills were worst. A separate study from Charles Darwin University documented the collapse of a dwarf population of freshwater crocodiles in upstream river sections. That population went from 28 individuals to 10 after the toads arrived. Not a percentage. An absolute number. 28 to 10. Animals that represent a genetically distinct lineage found nowhere else on Earth, now numbering in the low hundreds total, possibly fewer. 3 dead crocodiles found in 20 years of surveying before the toads. 34 in a single survey after. The mechanism matters. Understanding it is what makes this story so much worse than it first appears. Freshwater crocodiles are ambush predators. They sit still for hours, then strike fast. They are opportunistic. During the dry season, rivers contract into isolated pools. Every animal that needs water converges there. The crocodiles, the fish, the birds, and now, the cane toads. The crocodile does not see a danger. It sees food. A slow-moving, ground-level animal that doesn't flee, doesn't fight, and presents itself at the water's edge. From the crocodile's evolutionary perspective, 200 million years of it, that is the perfect prey. Easy, available, reliable. It strikes. It bites. Within minutes of the bufotoxin entering the mucous membranes, the cardiac rhythm breaks down. The crocodile goes into seizures. It loses muscle control. It rolls onto its back, not a death roll, not a fight, just a loss of physical orientation as the nervous system collapses. And it floats there, pale belly to the sky, exactly as the rangers found them. Still,
No wounds. No struggle.
no visible cause. This is what makes the cane toad unlike anything else in the crocodile's environment. Every other threat can be seen, heard, or smelled. Every other threat either flees, fights, or stays still. The toad does none of those things. It does not register as a threat. It registers as a meal. And by the time the crocodile's body knows the difference, the heart is already failing. Now consider what happens to the river when the crocodile disappears. The freshwater crocodile is not just a predator. It is a regulator. It controls fish populations. Its presence suppresses mid-level predators, water monitors, large snakes, opportunistic birds. When it hunts at the water's edge, it keeps the surrounding food web in balance in ways that took millions of years to establish. When the crocodile goes, those controls go with it. Georgia Wardfear has described what follows. When they decline, we see this huge hole in the ecosystem, and this kind of ripples out and sets off cascading impacts. A surge in mid-level predators. Bird nesting collapse in some areas as nest predator populations go unchecked. Native fish populations swinging wildly. The scavenger community shifting from reptiles to birds and mammals, disrupting decomposition rates across entire river sections. A 2021 study in the journal Ecosphere documented how the loss of large monitor lizards to cane toad poisoning more than halved scavenging rates in affected areas, changing the decomposition dynamic of the ecosystem at a fundamental level. The cane toad doesn't just kill the crocodile. It kills the role the crocodile plays. And that role, once gone, takes decades to rebuild, if it rebuilds at all. The Queensland government has identified 75 species of reptiles and freshwater turtles directly threatened by cane toads. Northern quoll populations have collapsed by 75%. Some goanna populations by 80%. A third of rainbow bee eater nests fail in toad-invaded areas because the monitor lizards that kept nest predators away are gone. One decision. In 1935. 200 million animals later. There is one more thing about the cane toad spread that makes this specifically, stubbornly unsolvable. It doesn't stop. 90 years of spreading and the cane toad has not reached the limit of its range. Research has found that in hotter, drier landscapes, exactly the landscapes where isolated dry season water pools force crocodiles and toads together, the toad's impact on crocodiles increases. The more arid the environment, the more lethal the encounter. Which means the frontier of this disaster is not behind Australia. It is ahead of it. Scientists have tried bounties, trapping, fencing, genetic modification research, biological control. 200 million toads later, none of it has stopped the advance. The only intervention that has shown genuine success at scale came from Wardfear's team in 2024, published in the Royal Society's journal. Taste aversion conditioning. Dead cane toads with the toxin removed, injected with a nausea-inducing chemical, left in the territory ahead of the invasion front. A crocodile that eats one doesn't die. It gets violently nauseated. It associates the experience with the toad's smell and appearance. In subsequent encounters, it avoids them. At Dungu Geeky Gorge National Park in Western Australia, the team placed nearly 2,400 of these bait toads in areas where the invasion front was approaching. Crocodile mortality rates at the treatment sites dropped by 95%. At nearby control sites with no intervention, the crocodiles kept dying. 95%. Not from a vaccine. Not from biotechnology. From teaching the oldest living reptile on Earth to feel sick when it smells a toad. The animal that survived the asteroid now needs scientists to teach it which frog not to eat. The freshwater crocodile is not extinct. In wetter, coastal regions with diverse prey, populations have held more stable. Some crocodiles in toad-invaded areas appear to have learned on their own to avoid the toads, shifting their foraging almost entirely into the water, where the current washes some toxin away before absorption. Behavioral adaptation is happening in real time, under pressure. But in the semi-arid gorges of the Northern Territory, in the upstream escarpments where the dry season forces crocodiles into small pools with no alternative prey, populations have not recovered. Some stretches of the Victoria River that once held 5 crocodiles per kilometre now hold fewer than 1. The dwarf populations that numbered in the low hundreds before the toads, genetically irreplaceable, found nowhere else, are at numbers where extinction is a realistic outcome, not a worst-case scenario. The crocodile survived the dinosaurs. It survived being hunted to near extinction by humans in the 20th century and came back after legal protection in 1971. But it has not evolved, in 200 million years, to be suspicious of a fat, slow-moving amphibian that doesn't run from it. Because in 200 million years of evolutionary history, nothing that looked like that was ever dangerous. That was always the strength, until it became the vulnerability. The cane toad killed the crocodile with its own instincts. The confidence built across geological time. The certainty, earned through every ice age and extinction event, that anything slow and available at the water's edge is food. It was never wrong. Until 1935. What this story asks you to sit with is not easy. The most ancient reptile on Earth, 200 million years of survival, no natural predators, outlived the dinosaurs, being killed in the thousands by something it could swallow whole. Something not hunting it. Something not even aware of it. Something that just sits there and waits for the crocodile to make the decision that has never been wrong in the entire history of its species. The danger was never the animal with the biggest teeth. It was the one that looked like an opportunity. In Australia, that thing hops.